In the quiet darkness of space, telescopes around the world caught something they weren't supposed to see. Behind the glowing trail of 3I/Atlas, 9 faint shadows appeared, moving together through the stars. At first, scientists thought it was a trick of the light, a glitch in the data, but the more they watched, the clearer the pattern became. These objects weren't drifting randomly. They were following the same path, keeping almost perfect distance, like a silent convoy crossing the solar system. No natural explanation made sense. Some astronomers called them fragments, others whispered about controlled formation. Each new frame of data only deepened the mystery. If 3I/Atlas is truly an interstellar visitor, what are the 9 following it? Are they its debris or its companions? And if they are moving with purpose, then whose purpose is it? For most of human history, the night sky was predictable. Every star, every planet followed the rules of gravity and light. But in 2025, something entered our solar system that refused to obey those rules. Astronomers named it 3I/Atlas, the third interstellar object ever discovered after Oumuamua in 2017 and Borisov in 2019. Each of those earlier visitors was strange in its own way, but Atlas quickly proved to be stranger still. It moved too fast for the Sun to capture, traveling at speeds that carried it from the edge of the system toward Mars and beyond. Its tail glowed green instead of white, and its gases showed a recipe completely unlike any comet born near Earth. The world's best telescopes, Hubble, JWST, and Gemini, focused on it, collecting light that had crossed billions of miles, and yet, every new image only made the mystery deeper. Harvard astrophysicist Avi Loeb was among the first to suggest that Atlas might not be entirely natural. Its perfect motion and missing push hinted at something controlled, something built. Others warned that people were rushing to conclusions, but even the skeptics could not explain its flawless symmetry or its silent companions. If Atlas is truly just a comet, why does it behave like a machine? And if it isn't, what could it be? When astronomers first aimed their telescopes at 3I/Atlas, they expected to see what they always saw: a dim, icy rock-shedding gas as it approached the Sun. Instead, what they found stunned them. The comet was glowing bright green, a color so intense that even amateur telescopes could capture it from Earth. It wasn't just beautiful, it was wrong. In the language of space, color tells the story of chemistry, and Atlas was speaking in a dialect no one recognized. Most comets turn green for a simple reason. When sunlight breaks apart molecules of diatomic carbon known as C2, the gas glows with a green light. It's a classic signature, one that astronomers use to confirm a comet's makeup. But when the first spectral readings of Atlas arrived, something didn't add up. The green was there, vivid and steady, but the amount of C2 was far too weak to create that brightness. It was like hearing a loud song but finding no speakers in the room. Scientists double-checked their instruments. The readings were clean. Every major observatory confirmed the same thing. The gas responsible for the glow was missing. That meant something else was causing the light. The question was, what? Some thought it could be carbon monoxide, a molecule common in colder regions of space. Others suggested that carbon dioxide might be reacting with sunlight in an unusual way, but no one could reproduce the same color in laboratory tests. The green of Atlas didn't match any known chemical model. The mystery deepened in September 2025 during a lunar eclipse. Under the shadow of Earth's moon, Atlas should have dimmed. Instead, cameras captured it shining brighter than before. Its glow cutting through the darkness like a signal. Observers in Chile and Hawaii described it as unnaturally pure, a green that looked almost electric. For a moment, it felt less like a comet and more like a beacon. To many scientists, this was impossible. The comet was too far, too cold, and too small for such power. Yet the data was undeniable. The color stayed consistent for weeks, even as the comet moved away from the regions where sunlight should have driven chemical activity. Whatever was lighting it up was not just a surface reaction, it came from deep within. Some researchers speculated that Atlas could have internal heat pockets, storing energy from its journey through interstellar space. Others wondered if its ice contained trapped gases reacting slowly as the comet rotated. The idea that the light might not be natural at all soon entered the conversation. A few dared to ask if the glow could be artificial, perhaps the byproduct of some unknown process or technology. The thought was controversial, but it spread quickly. Harvard's Avi Loeb called it a clue worth paying attention to, reminding his colleagues that every strange signal begins as a question no one dares to ask. If the glow was indeed artificial, it would mean 3I/. Atlas wasn't just carrying the chemistry of another world, it was carrying a message. Every photon could be data, a transmission encoded in color. Even if that sounds far-fetched, the comet's behavior was forcing experts to consider what once seemed unthinkable. The truth remains hidden behind its light, but the green hue, stubborn and unexplained, keeps haunting the observatories that track it. In a sky filled with predictable stars and ordinary comets, Atlas stands out like an intruder wearing a color nature didn't choose. If the light is not from the sun or its gases, then where does it come from? And more importantly, what is it trying to tell us? When astronomers began studying 3I/Atlas more closely, they expected it to behave like other comets. Ice should melt as it nears the sun, releasing water vapor and dust to form a tail. Water is the key ingredient in every comet known to science. But Atlas ignored that rule. When its chemical composition was analyzed, the results shocked everyone. Water wasn't dominant. Instead, the comet's gases were filled with carbon dioxide. The ratio between CO2 and water was completely reversed. This was not a small deviation. It was a fingerprint of another world. Such a mix could only form in a place far colder than the outer edges of our solar system, a place where sunlight is too weak to melt even frozen gases. It suggested that Atlas came from a region orbiting a dim star, where the chemistry of creation followed an entirely different rulebook. That finding changed the meaning of the comet itself. Atlas wasn't just passing through our system, it was carrying the memory of another. Each molecule inside it had been formed billions of years ago under foreign skies and preserved through endless travel. It was like a messenger made of ice, crossing interstellar space to show us what distant stars can build. Along with carbon dioxide, astronomers detected carbon monoxide, traces of water, and grains of ice mixed with unfamiliar dust. These ratios didn't match anything we had measured before. It was as though someone had rewritten nature's formula, replacing the water-rich chemistry of our comets with frozen gases and alien materials. The discovery confirmed that Atlas did not belong here. It was physical proof of another planetary system, one that had shaped worlds from substances we barely understand. Observatories around the globe verified the same result. The Hubble Space Telescope, Gemini North, and the James Webb Space Telescope all recorded identical readings. These weren't instrumental errors. The data was consistent, clear, and impossible to dismiss. Atlas carried the molecular signature of a solar system far beyond the reach of our own star. It might have been born in the remnants of a dead planet-forming disk, long ago torn apart by gravity or collision. Scientists began imagining what that world might have looked like. Perhaps it orbited a red dwarf star that shone dimly, where temperatures never rose above freezing. In that icy cradle, gases like carbon dioxide could freeze solid, merging with dust to form icy bodies. One of those bodies might have been thrown out of orbit during a planetary collision, beginning a slow journey across the galaxy. After millions of years, it entered our solar system and we called it Atlas. This idea fascinated astronomers because it expanded how we think about life and creation. The chemistry of Atlas suggests that not every world is built on the same foundation as ours. If other systems make comets with this kind of balance, then they could also make planets with carbon-based oceans, frozen CO2 clouds, and climates that never thaw. It means the diversity of worlds in the universe could be far greater than we ever imagined. Harvard astrophysicist Avi Loeb described Atlas as a time capsule of another solar system, a relic holding the blueprint of alien formation. He said its ingredients are clues, not only to where it came from, but also to how vast and inventive nature can be. Our solar system, he explained, is not the standard. It is just one version among many. For the scientific community, Atlas became more than a comet. It was a messenger that carried evidence of creation written in another language. Its composition told a story of loss and survival, of a world that may no longer exist, but left a frozen echo drifting among the stars. If every atom inside Atlas comes from another sun, then it is not just a visitor, it is a survivor of an ancient system long gone. And if there are more like it crossing the darkness, how many forgotten recipes of life are still waiting to be discovered? When scientists observed 3I/Atlas through polarized light, they discovered something that challenged everything known about comets. The way Atlas reflected sunlight was completely reversed. Instead of scattering light like every comet ever studied, it twisted the reflection backward. The phenomenon, called extreme negative polarization, meant that light from Atlas was behaving in ways no one had seen before. It was as if invisible hands were turning the rays around in mid-air. Normally, sunlight hits a comet's dust and ice, and the light scatters in predictable directions. This allows scientists to measure the size and texture of the dust grains within the coma. Every comet studied follows the same pattern. Brighter light appears when the comet is viewed from certain angles, dimmer light when it is not. Atlas broke that rule entirely. Its brightness dipped when it should have risen and glowed most when it should have dimmed. At first, research teams thought something was wrong with their instruments. Telescopes in Chile, Spain, and Hawaii were recalibrated, yet every reading returned the same result. Atlas was reflecting light backward with uncanny precision. The shift in polarization didn't fit any model known to physics, and the angles at which it flipped were beyond anything recorded. The dust around it appeared to be made of material that obeyed no natural law of reflection. One theory proposed that the dust was made of extremely fragile, porous ice composed of delicate clusters of tiny crystals. Another idea suggested the presence of exotic minerals, possibly metallic or glass-like compounds forged in the deep cold of another star system. These possibilities pointed to one conclusion: Atlas's dust was alien. It carried the chemical memory of a world born far from the sun's heat, a fragment of a system that might have died long ago. For astronomers, it was both thrilling and terrifying. The comet's behavior mirrored optical effects seen only in human-made metamaterials. Substances engineered to bend light in unnatural ways. No one claimed Atlas was artificial, but the resemblance was eerie. If nature could produce such precision, then either it was mimicking technology or technology itself had once learned from nature on a cosmic scale. Even more mysterious was the fact that Atlas's light remained stable for months. Normally, a comet's brightness shifts as solar heat melts its surface, altering the shape of its coma. But Atlas did not change. The polarization held steady, as though the particles were adapting to sunlight in real time. Some scientists described it as a system in perfect equilibrium. Others whispered that it almost looked intentional. That perfection raised disturbing questions. Could Atlas be maintaining balance by design? If its dust was arranged in layers or controlled by hidden processes, its light patterns could be the product of structure, not chance. Nothing in nature should remain that consistent over such distance. Yet Atlas refused to behave randomly. Its light seemed disciplined, conscious, and deliberate. Harvard astrophysicist Avi Loeb called it a cosmic contradiction. He reminded his colleagues that light never lies about what it touches. If Atlas could twist light itself, he said, then maybe it was showing us that not all intelligence uses words. Skeptics warned that mystery doesn't always mean artificial design, but even they admitted the comet's surface was unlike anything seen before. Now, as Atlas moves closer to the Sun, telescopes across Earth and orbit are watching. Every reflection, every photon, could be part of a story we have yet to decode. Until the mystery breaks, Atlas remains a mirror of the unknown, a glowing question that stares back at us from the dark. If its dust can bend sunlight itself, then what could it teach us about the nature of light and the things that choose to hide within it? When astronomers track comets, they always look for one small but important clue: the gentle push caused by sunlight heating the surface. As a comet warms, gas jets burst from its ice, giving it a non-gravitational nudge that changes its course slightly. This invisible thrust is like a signature, proof that a comet is alive and active. But when scientists studied 3I/Atlas, that push was missing. For months, telescopes across the world recorded its path. Every point of data showed the same thing. Atlas was gliding smoothly through space, guided only by gravity. Even though it had a glowing tail and an active coma, there was no measurable acceleration. It was as if the comet had chosen to ignore the sun's pull. In thousands of observations collected between May and September, not a single sign of non-gravitational movement appeared. This absence puzzled experts. If Atlas truly released gas, it should have drifted slightly off its orbit. The fact that it didn't mean something extraordinary. Either the object was far heavier than any known comet, or its outgassing was so perfectly balanced that every jet fired in an opposite direction, canceling the motion. Both ideas seemed impossible, yet both fit the data. The first theory suggested that Atlas was enormous. If its nucleus stretched over 5 kilometers wide and was packed with dense rock and metal, its mass could exceed 30 billion tons. A comet that heavy would barely feel the effect of gas escaping its surface. For comparison, it would outweigh several Mount Everests combined. If true, this would make Atlas one of the largest interstellar objects ever seen, a wandering mountain of ice and stone from another star. The second idea was even stranger. What if the comet was venting in perfect symmetry? If every jet of gas released matched another jet on the opposite side, the overall force would cancel, creating a stable, unshifting path. Nature rarely works with such precision. Even the most regular comets vent unevenly, their jets flickering randomly as they spin. For Atlas to maintain perfect balance would mean either coincidence beyond imagination or control. The thought of control changed the discussion. Could the missing push mean that Atlas was not entirely natural? Some scientists quietly admitted that its movement looked engineered. The idea was controversial, but the evidence kept growing. The comet didn't tumble chaotically like most frozen bodies. Its rotation was steady, its orbit clean, and its trail never wavered. Nothing about it seemed random. Harvard astrophysicist Avi Loeb revisited the data and noted that the lack of acceleration could point to internal structure. Perhaps the surface was sealed, preventing gas from escaping, or maybe the material inside was not ice at all. Some speculated it might be metallic, absorbing sunlight without releasing vapor. Others proposed that the object was hollow, with layers that absorbed heat differently. Each theory only deepened the mystery because every answer raised more questions. If Atlas was solid, how could it form in the cold vacuum between stars? If it was hollow, what had created such a shape? And if it truly was venting evenly, what natural process could achieve that kind of precision? None of the possibilities fit comfortably within the rules of ordinary physics. The comet was behaving like a spacecraft designed to move exactly as it wished, unaffected by the chaos around it. To this day, scientists continue to debate which explanation makes sense. Some believe Atlas's immense weight hides the push from our instruments. Others think symmetry is the key to releasing gas in a way we've never observed before. But there's also a quieter group that wonders if the answer lies somewhere beyond the boundaries of science. If an object from another star can glide through space without the slightest push or pull, could it mean it's not drifting at all, but navigating? When astronomers first saw them, the data looked like an error. 9 faint objects trailed behind 3I/Atlas, moving in perfect formation. Each was small, almost invisible, but their symmetry was impossible to ignore. They followed the interstellar traveler through the void, keeping equal distance as if linked by an unseen force. At first, scientists thought they were fragments of debris, torn off by sunlight or collisions. But fragments scatter and drift apart. These 9 didn't. They moved as one. Images from Gemini South confirmed the discovery. Across multiple frames, the 9 objects kept the same spacing, gliding behind Atlas like shadows bound to its path. None showed the chaotic trails expected from dust or ice. Their motion was deliberate, as if guided. Speculation spread quickly. Some compared the sight to the broken chain of comet Shoemaker Levy 9 before it struck Jupiter. Yet Atlas's companions behaved differently. Shoemaker-Levy's fragments stretched unevenly, shaped by gravity. The 9 followers of Atlas ignored such disruption. Their order never changed. One explanation suggested gravitational resonance, a fragile balance allowing the bodies to orbit in harmony. But for that to work, Atlas would have to be far heavier than any known comet. Another theory imagined them as connected parts of a single structure, a chain broken but not destroyed. If true, Atlas could be the core of something once vast, with 9 remnants still orbiting it like satellites. More data deepened the mystery. Observatories detected small variations in how each follower reflected light. Some glowed faintly green like Atlas, while others shone blue or metallic. The differences meant they weren't made from the same material. If they had split from one body, their chemistry should match. Instead, it seemed as though each came from a different source but moved together for a reason. Harvard astrophysicist Avi Loeb called the pattern too intentional to dismiss. Even human spacecraft struggle to maintain such perfect formation over millions of miles. For 9 natural bodies to do it without visible force defied logic. Some proposed magnetic fields or plasma interaction, but there was no supporting evidence. Whatever connected them wasn't gravity alone. Radar soon revealed subtle timing delays in their reflections. Each object responded to sunlight or radio waves at slightly different intervals, as though synchronized. These weren't strong enough to prove communication, but the pattern suggested awareness. If it was a coincidence, it was the most coordinated one ever recorded. Skeptics urged restraint, reminding others that nature can create order from chaos, yet even they admitted this level of stability was nearly impossible. Debris clouds should scatter within weeks, blown apart by solar wind. The 9 shadows, however, stayed steady for months, orbiting behind Atlas like loyal companions following their source. 2 major interpretations emerged. One saw them as natural fragments orbiting a massive nucleus, stabilized by Atlas's gravity. The other believed they were controlled, perhaps components of an artificial convoy crossing our solar system. Both sides agreed on one thing: the 9 objects are real, and their synchronized motion cannot yet be explained. As Atlas approaches the Sun, telescopes continue to monitor the strange fleet. Scientists hope one will break formation or reveal what holds them together. But none have drifted. They move quietly, in perfect unity, glowing faintly like sentinels in the dark. Whether natural or something far beyond it, their presence changes how we see the visitor known as Atlas. It is no longer a lone traveler, but a leader of 9 shadows that obey no known law of space. If these companions aren't fragments, then who or what taught them how to follow? The deeper scientists look, the stranger 3I/Atlas becomes. What began as a distant comet has turned into a riddle written across the stars. Its missing push, its unnatural light, and its 9 silent followers all point to something beyond our understanding. Each new discovery feels less like a solution and more like a message that the universe has been sending for a long time. As Atlas moves closer to the Sun, telescopes across the world are waiting. Some expect it to break apart and vanish. Others believe its true nature will finally be revealed. Whatever happens, this object has already changed the way we see the cosmos. It has reminded humanity that we are still students in a vast classroom of mysteries, and the test is only beginning. If Atlas was sent here with a purpose, maybe the real question isn't what it is, but who or what is listening back.